I sort of pointed out the thing in terms of normalizing to the shale. I think Dave, when he was just talking about that correlation of the well log to the actual seismic, is another way of actually getting things corrected to actual reflectivity units that you now can compare to actuals. So it's yet another method, and as I go through and we start talking about normalizations and get into exercise 5, a large portion of that's going to be focused on how do we go and get that conversion, that millivolts to reflectivity units conversion that Dave was showing there. So, okay, we're going to start on exercise 3. This one is based off the rock physics spreadsheet, so that if you're following along at your little workflow, we now have gotten up to rock physics. Okay. And this one, we're just going to go and examine this spreadsheet as a very simple calculation unit. We're not going to go and use this Monte Carlo thing of forming up hump plots. We're just going to see the way that this spreadsheet works in terms of the straightforward combination of the different expressions that Dave, and predominantly Dave, and to an extent myself, have supplied for you. A little bit of historical note, this is how this spreadsheet started. It was my little rock calculator of point-by-point values, and then it got layered on top of it the Monte Carlo engine that we'll experience in exercise 4 after we do the second part of the lecture later this afternoon. Okay. As a particular, again, you go into the exercise 3 area. There's also the exercise 3 instructions here. And this is really for you to go and substitute in different values and to fill out a little spreadsheet. In fact, you're going to be making some of the figures that Dave was showing earlier in some of the lectures. And let me go and orient you a little bit to the 2 spreadsheets to get you going. And again, I caution you, copy, paste, special. Okay, I'll close up previous results. Okay. And I'll go up and into exercise 3. I'll go and open up the rock physics spreadsheet, enable macros, even though you won't be using them. And also you want to open up this little analysis spreadsheet. And what you'll see are yellow cells, and these are what you need to fill in. And what we'll do is to go and vary the saturation and the net to gross. First of all, you see we vary the saturation. Then we vary the net to gross. Okay. Then we actually vary the saturation again. Okay. In fact, we do it in a way that sort of makes a loop. And the way that you'll want to do this is to go over to the rock physics spreadsheet. That you'll see that there's the net to gross sitting here, that there's a saturation sitting here. The active cells are the yellow ones. The other ones are just sort of suggestions coming from a trend and really utilized in the metropolis. So again, focus on the yellow cells here for inputs. The outputs are sitting over here on the right-hand side, and let me go and get everything, get the second half here, so I can open this up a little bit more. I'm gonna have to do this here first. Okay, there we go. Now, what you want to do is set, let's see, the first net to gross and saturation that I needed, let's take a look at this other spreadsheet, is 100%, 100%. So I'm going to set the net to gross to 1 and the saturation to 1. And then the outputs here show a couple different things. Given what the sand is and the shale, the bounding shale and the mixing shale, we do allow two different shales, one to be mixed with the sand and the other to be beside it. You can think about why we actually allow two, and maybe a question will come up to allow me to go into another little mini lecture there on that, but I'll avoid that for the time being. But then given what the particular reference sand is, that it will first go and mix this brine and hydrocarbon together with this saturation to get this particular fluid. You'll then take this sand and do a Gaussian substitution in it in order to get the VP, VS, and rho of this sand with this fluid in it. It takes out the reference fluid, which is a reference brine, and puts in a mixture of the in situ brine and the hydrocarbon. Okay? You notice though it gives you a couple other interesting numbers. Here are the ones it calculates, but it also gives you the phi, which is the porosity of the sand. It also gives you the beta. That's, K matrix over K grain. So we can see the beta of this is 0.15. And also a measure, a dimensionless measure of the shear rigidity of the rock, as well as this is the compressional rigidity. And then it goes and mixes this sand with this shale in order to give you the sand-shale mix according to the laminated mixture formula. Then it contrasts this sand-shale mix against this bounding shale, and then calculates the intercept and slope, the L and M values, and then also will calculate for two particular angles of incidence what the reflection coefficients are, okay? And so here are the reflection coefficients. Here are the L and M, the slope and intercept. This is that normal incidence reflection coefficient, and that's that coefficient that goes in front of or behind the theta squared term or the sine squared term. Now for this, I asked what is the VP, VS, and rho of the sand-shale mixture. So for this, you just want to copy and go over here into this point and just do an edit and this do a paste special values in order to get the VP, VS, and density of that particular mixture. And then also go back here and you want to get the reflection coefficient, but I'm going to do, since this is Excel, actually sort of cheat, do this in order to make my life easier and be able to get everything at the same time. And then go back into the analysis, go here, and do edit and paste special values. Okay, and now I've gotten everything that I need. Okay? And again, it's sort of right there for a second. You actually saw an advantage of being able to, the fact this is in Excel. I was fairly quickly able to make my life quite a bit easier. And also it's easy to cut and paste the results from one spreadsheet into another. Okay? And so just go around and do a bunch of point and click. And as you do this, there's another tab down here, which are graphs. And as you go and start putting in your results, you can see where they come out graphically. And you'll start recognizing some of these plots. And I'll discuss them a little bit more after you can have completed the exercise. Okay? Okay, have some fun.